Welcome to SOEE5582 Tools and Techniques for Ecological Economics. My name is Jonathan Bush and I am the module leader for this module. I don't teach all of this module by myself. I have a fantastic teaching team that's going to help me deliver the various parts of the module. But if you have any questions about the module as a whole, I'm the person that you should turn to in the first place. So the whole teaching team consists of myself and 3 other academics from the School of Earth and Environment. There's Dr. Katie Rolick, who's an associate professor in our school, Dr. Milena Books, who's also an associate professor in the school, and then Dr. Lena Brandt-Correa, who is a postdoc and teaching fellow working with us. And we also have 4 demonstrators who will be there to help us in the live sessions and also to help answer any questions that you have in between live sessions when you're working on materials. The 4 that we have, 3 of them are maybe a little bit shy. I couldn't find pictures of them, so you'll have to wait to see them in the live sessions to know what they look like. But all of them are Emmanuel, Marta, Zeke, and Suzanne, and they are PhD students in the department, and they actually work in their research using some of the tools and the techniques that we're teaching in this module. So they are great people to have on board for the teaching. So what are we going to do in this module? In a minute, I'm going to go through in detail what the timetable for the module is. But broadly speaking, the module is looking at 4 different computational tools and techniques that ecological economists use when they want to understand the behavior of environmental, social, and economic systems and interactions between those systems. The general philosophy of this module is really based on the foundations of ecological economics, and particularly 3 concepts, 3 ideas that make up how ecological economists view the world. The first thing is that, and that's really core to the kind of tools that we use in this module, is the idea of complexity. That sustainability challenges the things that ecological economics concerns itself with, the problems in the world that it concerns itself with, like climate change and the biodiversity crises, are things that are inherently complex in the sense that you can effect change in a system, you can have some intervention acting on a system, and then it's not easy to see what the outcomes of that are going to be. Okay, so there's no easy way to interpret from the inputs what the outputs of an intervention are going to be. It's that kind of understanding of complexity. The other ideas, the other 2 concepts that I've put together here are this idea of embeddedness and interactions. So embeddedness is really about understanding the economy as being a system that is embedded within a wider social system. And that social system in turn is embedded within an earth system. It's part of an environment. Okay, so understanding the economy, you also have to understand how it interacts with social systems and with physical environmental systems, and that the flow of materials and energy that take place in an economy are fundamental to understanding the dynamics of an economy. So sustainability issues have been studied in other academic disciplines, particularly in environmental economics, but also transport studies looks at some of these kind of issues. So for example, you look at the impacts of transport pollution on the environment. There's a lot of work on the economic costs of resources. There's a huge field of energy economics as well, for example. The difference really with this approach is that we're trying to study the interlinkages between so many of these systems. Right? This embeddedness and complexity implies that we have to have a more holistic approach in our analytic frameworks. And that's really what we're trying to develop in this module. The learning outcomes, specifically for this module, the most important thing is that we want you to gain some familiarity with these kind of widely used tools and techniques, these research and modeling frameworks that are used in ecological economics. Some of these are used incredibly widely, some of them less so, but we feel that they should be more used. There are reasons why they aren't, and we'll get into those. We want you to be able to develop simple models of the kind that we'll discuss, that you'll get to work with in the 4 sections of this module. We want you to be able to use the tools and the modules and the models that we work with to analyze the effects of interventions. So what happens if we have a policy change in a particular system? What will the impact of that be? How can we assess that with the tools and models? And we want you to be able to interpret and analyze the results of these models. We're not going to make you experts in modeling. Okay, that is not the point of this. We've only got a couple of weeks to cover each tool and technique. So that means they're really introductions to those. So you'll understand what the basic ideas of these tools and techniques are, and you'll be able to work with simple examples of them, and you'll be able to go away and study it in more detail and work on becoming an expert if you so desire. But we don't have the time to really develop, in-depth skills in each of these techniques. There's also some really useful transferable skills that you should gain from this module. So first of all, we use 3 different software tools throughout the module. So we have VenSim and NetLogo that are used for system dynamics and NetLogo. And then we use Python for the second half of the module. So you'll gain some familiarity with these kind of software tools and you'll be able to use them going forward. And then there's also the kind of analytic and data analysis skills. We'll be dealing with doing some data analysis using Python. So you'll learn all those kind of skills that are much more widely applicable than just the techniques that we're using in ecological economics. And then also this whole process of developing system representations, developing models, implementing models, exploring scenarios is not specific to ecological economics. So you can take these kind of skills and apply them in other areas as well. So those are really very transferable skills. The 4 methods that we look at are, first of all, system dynamics modeling, which is a very kind of top-down modeling perspective. The most famous example of that is probably still the World 3 model, which was used in the Limits to Growth report. So we'll talk about that a little bit in that part of the course. The second tool that we use, the second technique that we look at, is agent-based modeling. And that's the part of the module that I lead the actual content teaching of as well. And that's, in contrast to system dynamics, it's a very bottom-up modeling approach. So you're looking at explaining the behavior of a system from the perspective of individual agents who interact, and agents represent people or households or communities, this kind of thing. So the third part of this course is looking at environment-society interactions. And that's looking again from quite a macro perspective at how are things like affluence and GDP and environmental indicators like carbon emissions related, and what kind of statistical analysis can we perform with that to understand what causes those linkages and how they might evolve into the future. And then the final 4th part, the 4th technique that we look at, is environmentally extended input-output modeling. And that's a more specific accounting technique that's used quite widely at this point. It was pioneered and sort of introduced in accounting that's done by the UK government, by people in our department. And what it does is look at, rather than accounting for carbon emissions in the territory that they occur, how do we account for those emissions based on the consumption of goods and services that has caused those emissions down the whole supply chain. That's very vague. We will explain that to you in much more detail when we get there. So the module structure. In this module, as you've probably seen on your timetables, we will have live sessions that are 2 hours every week on a Tuesday. So they run 10 till 12 every Tuesday. Those will be led by one of the topic leaders with a couple of demonstrators there, and all of the students should attend those sessions. In those sessions, we'll discuss the papers that have been set for readings every week. We'll have some group discussions, and we'll also do some live exercises in those sessions. So those are really going to be important for you to understand and be able to engage with the material that we're teaching. As well as that, there'll be some online preparation to do, which will usually be released every Tuesday after the live sessions. And that consists of some pre-recorded presentations like this one. There'll be some core readings listed, which you should try and read before the session. It's really important that you get through those so that you're able to participate in the group discussions properly. And there'll also be lots of exercises. So this is a bit of a flipped classroom kind of experience where we expect you to do quite a bit of the programming work in between sessions, and then we go over to make sure that you've done it correctly. And whilst you're doing that preparation work on your own, you can also use the discussion boards and email if you have more substantial questions or you're stuck on a particular bit of programming. So that's the way the module is structured, broadly speaking. More specifically looking at the schedule, so we've got the first week, week 14, is a bit of a light week. There are some readings that you should do, but it's mostly an introduction to the module. So we'll have a bit of a live session where we all get to know each other a little bit and talk about kind of broadly what the whole module is about. Then the first topic that we'll tackle is system dynamics. So that'll be the next 2 weeks, led by Dr. Katie Rolick. Following that, I will be leading agent-based modeling. Then we will set you the first assignment. I'll say more about that in a moment. And then after that, we'll move on to environment-society interactions for 2 weeks, which Milena will be leading. And then the final topic, led by Lena, will be on input-output analysis. And we're quite lucky this year that we can actually finish all of the topic work, all of the content that you need for the assignments before the Easter break. So the first assignment covering the first 2 topics will be due still before Easter. And then the second assignment, you'll have the Easter break to work on, and that'll be covering the environment-society interaction and the input-output analysis topics. And then after Easter, the only thing we have left is a wrap-up of the module, which I'll be leading again. Okay, so the last thing for this video, I just want to talk about the assessment that's part of this module. So we've got 2 assignments. The first assignment is worth 50% of the module grade, and the second assignment is worth the other 50% of the final grade for the module. And they cover the 2 first topics and the 2 second topics. So for the first assignment, you get to choose between doing a project on system dynamics or a project on agent-based modeling. And for the second, you get to choose between doing one on environment-society interactions or on input-output modeling. Both of them require you to write a 2,000-word report, and the details of what you're asked to do for them will be in assignment briefs that I'm going to put on Minerva closer to the time when we actually set these. The reports should be submitted on Minerva, so the usual way that we do in Leeds. I've given you the deadlines already in the previous slide. The model and data files that come with the work for these assignments, you'll have to email to the topic leader. So again, I'll mention this again when we get closer to the time. But that's where your grades come from for this module, is those 2 assignments.